All right, the lesson today is 7.7, writing equations from zeros and degrees. So essentially what we're doing here is before you found the solution sum on the calculator, sum through synthetic division, and then you found the rest of them by factoring and finding the solutions from the factors. What we're going to do here is you're going to be given all the solutions, all the information, and we're going to work backwards. You're going to write the solutions as factors and then distribute and FOIL the factors back as the original polynomial, kind of like how the problem would have started. So essentially, when you are given a zero or a solution, the factor must have been x minus that zero. So whatever that answer is, like answer was 3, x minus 3 is the factor. So if 2 is a zero, then the factor is x minus 2. When given a list of zeros, write out the polynomial in a factored form. So for example, if we have the zeros 2, -3, and 5, we would write the factors as x minus 2, x minus -3, or x plus 3, and then x minus 5. Then we would distribute to write out the polynomial in standard form. Just do one pair at a time. Don't try to distribute all three all at once. So for example, I would take just x minus 2 and x plus 3, and I would distribute those. Now there are some tricks you can do. Anything that you know to kind of shortcut it, you're more than welcome to do it. I'll just write this all out. So that makes x squared plus 3x minus 2x minus 6, and then always combine like terms if you have any before you work with the next factor. And I'll just bring that x minus 5 down, and I'll distribute one more time. So distributing this, x cubed minus 5x squared plus x squared minus 5x minus 6x plus 30. My final polynomial answer is x cubed minus 4x squared minus 11x plus 30. And that's where we'll just leave the final answer like that. Sometimes you'll get zeros as the number 0 itself. So for example, if we have zeros 2, -4, and 0, you'll have factors x minus 2, a factor x plus 4, and then this factor 0 will just be a factor of x. And then you'll distribute like we did before. The trick with this one is that x factor, distribute that last, because it's always really easy to distribute an x. So let's try distributing the x minus 2, x plus 4 first. X squared plus 4x minus 2x minus 8 combine like terms. And then distribute that x. So the final answer is x cubed plus 2x squared minus 8x. And that will be your final answer. Now, sometimes you'll have problems that have what's called a multiplicity. So if you recall what multiplicities are from the last test we had, basically it tells you how many times the factor or the zero repeated as a solution, the frequency of it. So sometimes you'll get problems like, well, here's your zeros, 2 and -3, but it says that -3 has a multiplicity of 2. What that tells me is that we have one factor of x minus 2, but then this -3 zero, because it has a multiplicity of 2, we have factors x plus 3 and another x plus 3. So in the end, we have x minus 2 and x plus 3 squared. And you'll still distribute these like we did before. If it helps to write it out, x plus 3, you may. Most of you should know how to do x plus 3 squared, and I would always recommend doing that first because there is a pattern with that. And if you recall, it goes x squared, 3 times x doubled is 6x, and then 3 squared is 9. And then distribute the x minus 2 at the end. So x cubed plus 6x squared plus 9x minus 2x squared minus 12x minus 18. Combine like terms. And again, we'll leave that as our final answer. You'll have at least one problem where it will only give you one zero, and it will tell you the degree of the polynomial. So to review what a degree means, it just tells you what is the highest exponent of the polynomial in the end. So this last problem we did, it has a degree of 3, since that's your highest exponent. So most of the problems will tell you what the degree is, just so you know what to expect in the end. So this one only gives me a single zero of 2, but it also informs me that it has a degree of 3, so it must be x cubed at the end. The only way we get that is if we write this factor out 3 times. So essentially, it has a multiplicity of 3. Now, you could write this as x minus 2, x minus 2, x minus 2, or you could write it as x minus 2 raised to the third power. Now, we haven't been taught any tricks of how to do a third power of a binomial, so it might just be best to write it out like this and just kind of distribute it one group at a time. So I know that 2 of these will make x squared minus 4x plus 4, as if I'm squaring it, and then distribute the x minus 2 a third time. So x cubed minus 2x squared minus 4x squared minus 8x plus 4x minus 8. And that will be my final answer. And lastly, sometimes you'll get zeros as imaginary answers, as you might have saw from the last homework. So if you ever do have an imaginary answer or a complex number as an answer, just know that its conjugate is automatically another 0. So imaginaries and complexes always come in pairs. So this would also note that, okay, here's your 2 zeros, 2 and 3i, but it's a degree 3. So that means there should be 3 solutions to this. The other factor that's missing here that they didn't directly tell you, we have x minus 2, we have x minus 3i, but x equals negative 3i is another 0. So we should have a factor of x plus 3i to represent the factor for that solution. So you just have to remember that imaginaries come in pairs. Now, the best thing to do for this is distribute the imaginary factors first. Otherwise, you get some crazy answers if you kind of mess up the work along the way, which is very easy to. So if I just distribute this, this is like difference of squares, multiplying conjugates. We square the first term, we square the last term, we always have subtraction in the middle. What you need to remember is that I squared is negative 1, and so that's really going to be a plus 9. Then you can distribute with the x minus 2. So x cubed minus 2x squared plus 9x minus 18 would be its final polynomial solution. So just kind of looking at the homework, you'll be given a set of zeros and they'll tell you the degree. So you're just going to set it up, x minus 2, x minus 3, x plus 4, and then start distributing. One pair at a time, get your answer, and then distribute with the x plus 4 and get your answer. If you have a 0 of 0, you'll do x plus 1, we have x minus 2, we have x minus 3, and then this 0 would just be x on the outside. And again, distribute that last. So you kind of FOIL those two, distribute and FOIL those two, and then you can distribute that x at the very end. If we have a degree of 3, that just tells you this 0, x minus 3, is written out at least 3 times. And then distribute all of that. If you have fractions, so this factor would be x plus 4, this 0 would be x minus 2, but then this fraction, to get that solution, you don't want to write it as x minus 3/4. Although technically correct, it's a little bit trickier to distribute with all those fractions. What we do instead is 4x minus 3. And the reason why that works is because you have this solved for, you would essentially add 3, divide 4. So it was always the opposite sign. This is the constant number, and then you're always dividing by that number. So that has to be with the x. That has to be the constant at the end. So just be careful with fractions. And I would write it out as 4x minus 3, for example. And then distribute those however you see fit. When you're given multiplicities, here they only gave me 2 zeros, but it should be degree 3. And that's because negative 2 has a double multiplicity. So we have factors x plus 2 and x minus 2. But because negative 2, which is actually this factor, has a multiplicity of 2, we will square that one. And then just make sure you square x plus 2 squared first, then distribute the x minus 2. And then finally, we get to some imaginary stuff, like here we go, imaginary right here. We have a factor of x plus 1. We have a factor of x minus 5i. And because by default, we have one imaginary answer, its conjugate, x plus 5i, is automatically another 0 and another factor there. And then distribute those imaginaries first. All right, and then these will be your problems, these first 11 right here. And then you will submit this onto Canvas whenever you are able to. If you have any questions, feel free to email me or ask me any questions online.